I told you that carbon nanotubes are not synthesized as a graphite sheet that rolls up, so how are they made? The mechanism is still not fully understood, but in this video I will show you the setup for the main different techniques used by scientists to produce carbon nanotubes. There are two main techniques. The first one to be used was arc discharge. This is the chamber for the arc discharge, which is filled with an unreactive gas. Inside, two rods of graphite will be placed and we will apply a current. One of the rods will be the anode and the other will be the cathode. When the two rods are brought together and the current is applied, a spark is produced between the rods, which instantly vaporizes the tip of one of the rods, and this carbon gas forms the nanotubes. Black soot is produced and starts to cover the whole chamber, including the window, so after a while we can't see anything anymore. When we open the chamber, we can see how the anode is being consumed, and the black powder is deposited everywhere around. On the cathode there is also black powder, where we will find carbon nanotubes, normally with 20 to 30 walls. Although if we also include a metal catalyst in the anode, we can obtain single-walled nanotubes. The nanotubes made with this technique are quite perfect, free of defects, but the problem is that there are another bunch of carbon forms that are also produced, so then it is very difficult to separate them. It's also hard to make a lot this way. The other main technique is chemical vapor deposition, but it is most commonly known by its abbreviation CVD. In this case, the starting material is not graphite but some carbon-based gas, a hydrocarbon. We also need a metal catalyst to form tiny particles which will act like seeds. In this CVD machine at Oxford University, the metal is included in the starting molecules. They use ferrocene, which contains one iron atom per molecule. The young scientist takes a clean tube and sets up the experiment. He introduces a clean base in the tube and closes all empty space with heat-resistant cotton to keep the heating. A non-reactive gas is passed through the heated solution of the hydrocarbon. The mixture passes through the furnace where the temperature can be from 300 up to 1150 degrees C. He can run the experiment for as little as 5 minutes up to hours in order to get longer tubes. Once the experiment is finished, he collects nanotubes from the soot stuck on the tube sides, and also the base, previously clean, which now has nanotubes all over it. CVD is probably the most promising method to produce carbon nanotubes for industrial use. It is easy to introduce other elements such as boron or nitrogen in the starting chemical. The diameter of the tubes can be chosen by the size of the metal catalyst particles. Also, we can grow the tubes on the surface, which helps for future applications. Arc discharge and CVD are the most common techniques, but there are others, like laser ablation. In this technique, a laser is used to vaporize the carbon atoms from a graphite target. Laser ablation normally produces single-walled nanotubes. Another less common technique is electrolysis. This technique is in some ways similar to the arc discharge, because it also uses two graphite electrodes. But in this case the electrodes are immersed in molten ionic salts. With this technique only multi-walled nanotubes are produced. They have very few walls, 10 to 15, and are normally bundled together. As you can see, there are different techniques to produce carbon nanotubes, and each technique produces nanotubes of different qualities.